Now, let's look at 2023 AMC 10B problem 14. It asks us to find the number of ordered pairs of integers m and n satisfying the given equation. To solve this equation, we will do the casework analysis in terms of whether one out of these numbers is equal to 0. In case 1, we restrict to, say, m times n is 0. In this case, we can see that for the left-hand side of the given equation, the middle term is 0. So the left-hand side is equal to m squared plus n squared. For the right-hand side is 0. So how we have m squared plus n squared to be equal to 0? The only solution is both m and n are 0. So in this case, we have one solution. Next, we look at case 2, where m times n is not 0. So in this case, both m and n are non-zero. Okay, so this becomes a number theory problem. And we make the following change of variable. Let me set k to be the GCD of m and n. So this allows us to write m in the form of k times u and n to be equal to k times v. So we are guaranteed that u and v are relatively prime. Next, let's plug k, u, and v into the equation given in this problem. So that equation could be equivalently written as u squared plus u times v plus v squared is equal to k squared times u squared times v squared. Now let's solve this problem. To solve this one, so the key condition we have to use is that u and v are relatively prime. So let's modulo this equation by u. Then the right-hand side is congruent to 0. For the left-hand side, modulo u, the first and the second terms are congruent to 0. So it requires the third term on the left-hand side to be congruent to 0 modulo u. So that means u must divide v squared. But recall that u and v are relatively prime. How v squared could be divisible by u? Then we must have that u and v must be equal to, each of them is equal to +1 or -1. Okay? So basically now it seems there are 4 different combinations of u and v. Both are +1, both are -1, and u is 1, v is -1, or vice versa. Okay? And let's plug them into this yellow equation. On the left-hand side, we have u squared plus v squared, so it's 2 plus u times v. On the right-hand side, we get k squared. And recall that each of u and v is either plus or minus 1, so their product of u times v must be either +1 or -1. So the left-hand side is either 3 or 1. But the right-hand side is a perfect square. So to make the right-hand side to be a perfect square, then we must have u times v to be equal to -1. So k squared is 1. Recall that k is defined to be the GCD of m and n, so k is positive. So this implies k is equal to 1. How to get u times v to be -1? So one number must be +1, another one must be -1. So this leads to 2 possible solutions for m and n. Either m is +1, n is -1, or vice versa. So in this case, we have 2 solutions. Recall that in case 1, we found one solution. By putting 2 cases together, the total number of solutions to this equation is 3. So the answer is C.